Okay, well, welcome everybody to the third Ideas on the Fringe event. Those of you who've been to the first two with Steven Pinker and Michael Sandel know the general format. Tonight's going to be slightly different. I want to start off by making some introductory remarks, but then I'm going to turn over to Ed, who wants to make a few remarks of his own, and then we'll engage in the conversation that's been typical for the previous two. So as many of you will know, Ed's been teaching here for a very long time in the Department of Why did I see there's a publication misprint last year in the Department of Orgasmic Evolutionary Biology, and it's so stuck in my head that I can't even pronounce it. So Ed, of course, has had a wonderful career engaging with many different aspects of biology, conservation biology, biogeography, and of course what many people know him most for is the early pioneering work in the field of sociobiology, which he synthesized in his 1975 book. And tonight what we're going to be doing is going into some discussions of a recent, about to be published book with his longtime collaborator, Bert Holdobler, called Supoerorganisms, and it will sort of travel across a variety of topics. But as a way of introduction, I want to start off with a personal story that took place in 1976 when I was a freshman undergraduate. In my first course in animal behavior, and the book was E.O. Wilson, Sociobiology. So this is really hot off the press, and I can remember reading page after page and thinking these ideas were incredible, the predictive power of the ideas, the scope of the problem, looking at all sorts of non-human animals and human animals. And it was a very interesting course because the professor, Douglas Candlin, who's a comparative psychologist, gave us only one graded assignment. And the assignment was, the final exam, one question. The question was, you've heard about a variety of figures in this field of sociobiology, both people pro and con, and you're now throwing a dinner party. And you get to invite 10 people to this party. What will they talk about? What will they argue over? So I had Ed facing off against Wynne Edwards, discussing the merits and virtues of different levels of selection, and having Ed argue in favor of selection at the level of either the individual or the gene, arguing against Wynne Edwards at the level of the group. And it was a fierce battle, and I think at some point I had maybe Ed throwing beer at Wynne Edwards or something. We got very, very kind of creative, and I got a very good grade, by the way. But there was a real issue at that time, and it's an issue that we're going to basically be starting off with tonight, which is how to think about questions like the evolution of altruism, the evolution of human morality, cooperation, in terms of levels of selection. At what level or levels does selection operate such that we can account for the kinds of social behavior we see in a variety of organisms? So what I want to do now is I just want to turn it over to Ed for a few minutes to give a few words on some of the ways in which his own thinking has changed over the last several years, where things stand today, and then we'll get into topics having to do with the notion of a superorganism, the evolution of morality, questions that bear on issues of conservation biology, and we'll be off and running. Ed.
Thank you. I think I need to turn this on, and we'll do so.
Do you want to? You're good. Yep.
Am I on?
Yes.
Good. Thank you for letting me speak first, because this is a now, once again, fast-moving subject. The controversies now involve in-group, that is, among specialists of theory on sociobiology. They have to do with the origin of altruism and of advanced social behavior, and particularly in the insects where we can deal with the problems substantively. And in fact, I'm lugging now the manuscript, the finished manuscript, with the editing going on of the book, The Supoerorganism, which is focused on the insects, where we have an enormous amount of new information. And I have not this time ventured forth into humans, not because I fear the controversy, but because we have now before us a task of re-examining the entire issue of multi-level selection, and of the origins of altruism and group loyalty and all of these things that concern us in the study of human behavior, but require major modifications and new issues examined, particularly with reference to what could be called gene culture coevolution, but we'll leave that for next year. Right now, I want to talk about social insects because, as I'll make clear in just these quick introductory remarks, here is where we can, possibly for the first time ever, see clearly what emergence is and what happens when you go from one major level of biological organization through what's called the great transitions. Then this one is the organism to the superorganism to the tightly organized colony whose organizational structure is based upon altruistic behavior. How did it happen? Where did it come from? But before I do get into this, I want to stress why this particular subject, however we address it, and whatever pairs of organization levels we investigate to study these transitions, we are headed now, I think, in the 21st century toward the possibility of a genuine unification of biology as a science. And I would like to be so bold as, in fact, to suggest that we now have two laws of biology. And of course, that'll get me immediately into a controversy, but let me just say this, and then, because I want to make a point with it, and then we'll go on around it. The first law of biology is that all entities and processes of life are ultimately obedient, note, ultimately obedient to the laws of physics and chemistry. And this is the foundation of molecular and cell biology. The second law of biology is that all the entities and processes unique to living organisms are the products of evolution by natural selection. That, in turn, is the foundation of evolutionary biology, very broadly defined. However, that this may turn out to be the case that we can call these authentic laws, these generalities can only take us so far. The unity of biology depends on something else, a full cause and effect explanation of the major transitions in the levels of biological organization, molecule to organelle to cell to organism to population to ecosystem. The units of each level at any of biological organization is an aggregate of the unity of level below it, with the lower units cooperative with one another to some degree. Their cooperating aggregates are the units of the next level above it. Well, that's a simple enough idea, but it's simple only in initial statement. The attention of biologists is turning increasingly to these transitions, and the progress is very rapid. The research is by definition interdisciplinary. It consists of systems analyses with a higher of any adjacent pair of levels, for example, of organism to cells being the system. To the extent that the transition analysis succeeds, the century of biology will become deservedly known as the age of synthesis. Not all of the transitions, though, as I indicated, between levels of organization are equally penetrable. The most accessible, as I just said, may well be that between the organism and the eusocial insect colonies, which can be treated as a form. The colonies can be treated as a form of organized populations. A eusocial colony, such as that characterizing ants, bees, wasps, and termites, is one in which reproducing members, as a reproducing caste or set of members, in the colony are supported by a cooperating non-reproducing members in the rearing of offspring. So this has to go on for more than one generation. The binding force of a eusocial colony is glue, is the altruism displayed by the non-reproductive members, usually called the workers. To understand the origin of a eusocial colony and the transition it represents, it is necessary to understand the origin of altruism. Now I'm going to explain very briefly what the evidence suggests about the origin of altruism and thereby the earliest stages of eusocial evolution in the insects that we can now address a little more confidently from the very large amount of information newly synthesized. This reconstruction, which has only recently been made possible by empirical studies, differs in some ways radically from the standard explanation that has prevailed for the last 40 years for reasons that I'll give very shortly. Differed, you can say, as primarily in perspective and the point of entry of the theory building and the models. Let me just tell you briefly what the standard theory is, or what at least it's often perceived as being the case, although not necessarily precisely that form that is used by the most creative mathematical theorists. It's getting very abstract and rather remote from reality, but originally, and this is what made sociobiology, one of the things that made sociobiology attractive intellectually was this standard way of looking at it. And the standard way is that in addition just to parents and offspring and the Darwinian evolution that occurs from the generation of offspring maximize the optimal by genetic fitness, which is the combination, the multiple of survival time and the number of offspring produced per unit time, that in addition to that, that you can reproduce your genes by favoring relatives that are collateral. And collateral relatives would be uncles, aunts, they'd be cousins, they'd be sisters, they'd be brothers, other than direct offspring. So collateral kin selection, it was called, was introduced and became a powerful theoretical tool and conception that interested people. If you could increase the fitness of your relatives, and this, the closer the relative, the better, then you would be sharing genes with these, so you could be altruistic. And if the altruism you showed was more than compensated for, that is how much you gave up, how quickly you gave up your life, or how fewer offspring you had, was more than compensated for by the offspring of the survival and offspring of your relatives, especially your close relatives, then you actually could have the evolution of a society with altruism, and that was it's a very nice, seductive idea, but that particular view of it has turned out to be, well, incorrect. And now I have to move to what, in my judgment, is from empirical studies alone, not from a prioristic model building of this kind that has prevailed, but what the evidence seems to show. And then I'll proceed to show that this leads to a very different perspective about multi-level selection, that is, natural selection going on at the level of the colony versus the level of the individual in particular. But first, let me just say that the origin of eusocial colony life, what you just go outside and see going on in ants and bees and wasps and termites, has been quite rare in evolution. This is an extremely important fact that we haven't given a lot of thought to. It never occurred, so far as we know, never once, any evidence that it ever occurred, this kind of altruism or eusocial organization, in the first great insect radiation of the late Paleozoic, and later in the Mesozoic, when the second great radiation was beginning of insects, diversification. It was, again, didn't come up until the mid-Mesozoic, and again was scarce. Now, this infrequency is due to two circumstances, and I will now tell you what they are, because now we begin the empirical-based explanation of what happened in the social insects, which provide for us, as I think, so different from human beings, yet exhibiting altruism and the like, systems so different in origin, the communication used, and everything else, that they represent a wholly different experiment in higher social organization. They're what you might expect to find, the sort of thing you might expect to find on another planet as having evolved there. Infrequency is due to two circumstances. The first is that the origin of eusociality requires a very specialized form of pre-adaptation. That is, Darwinian evolution has, during the radiation of the insects in all these different directions, has to hit upon one. This is Darwinian. That is, parent to offspring, no collateral altruism or selection going on. It's not in sight. A very form of pre-adaptation, which is the construction of a nest by the parent, followed by progressive provisioning of the young by the parent in the nest, like birds. Once this pre-adaptation is achieved, and now we're still strictly Darwinian, still individual level selection, only a single small genetic change, even the substitution of a single allele, is sufficient to set the stage to the transition, the great transition from organism to colony. And this is why the article that I have coming out in Bioscience in January is entitled One Great Leap, how altruism and higher colonial life originated in the insect. One small step for a wasp, one giant leap for the Hymenoptera. Okay. The prescribing allele must cause, it's easy to achieve this. It's just, this is the kind of thing you can achieve with a single allele, actually. Must cause the parents and offsprings to linger at the nest, and it must be, and this is something that's been missed by so many mathematical theoreticians who get all tangled up in trying to devise theory that can explain it otherwise. It must be plastic in expression. That is to say, the allele must have a phenotype that can produce, depending on circumstances, either a worker or a queen, or a royal male. And they either reproduce or do not reproduce while continuing the progressive care of the young. Plasticity of this kind actually was visualized clearly by Darwin. That's how he finally solved the problem of the social insects and the ants. He said, if I can't explain the altruism of these insects, then my theory is toast. And he spent a lot of time worrying about it. I have to tell you, I'm going to use up too much time, but I'm going to tell you a funny story about it. Darwin is told by one of his maids that she's looking out the window, and there's Darwin looking at an anthill for a long, long period of time. And she comments to a member of the family, incidentally, Thackeray, the novelist, is a close neighbor. And she said, what a pity Mr. Darwin cannot find something useful to do like Mr. Thackeray. At any rate, he understood. Well, the second reason, and that's so you've got to have just that, you've got to have set the stage, which is not that common. The second reason that eusociality has been a rare event in evolution is that the incipient group, once the step is taken, which possesses the altruism allele, has to do better than solitaires, which do not possess the plastic altruism allele. The allele, the evidence suggests that this selective superiority occurs when the nest site itself, happenstance, is situated so as to provide a rare, persistent bulwark against predators and other enemies, while lying within foraging distance of a relatively rich, persistent food source. In other words, here we have an allele that isn't going to work unless the group is superior over the solitaire, and this is a circumstance under which it works, but it apparently works only rarely. Now notice we're not talking about kin selection here in the usual sense. We're talking about competing alleles in a way in what is almost traditional lineal Darwinian evolution. So the whole situation may be that simple. So that's it. The bottom line, which does run counter to the conventional wisdom, is that group selection, the competition between groups, is the primary driving force of altruism and eusociality. And this is also important. Close kinship among the colony members, which undoubtedly occurs, close kinship among those members in the early stages, is the consequence, not the cause, of the origin of eusociality. Now, defenders of the standard theory, which has persisted for 40 years, starting with and I was the one that really made it popular in sociobiology and so on. Richard Dawkins came in and made it very popular, but I was the one that put a scientific basis to it. At any rate, defenders of standard theory, starting with the inclusive fitness of individuals that possess the altruism gene or do not possess it, covers the case just cited, but it does so at the price of changing relatedness and kinship to mean as little as the probability of multiple individuals possessing the altruism allele, and further, of including direct offspring in the calculation of inclusive fitness. When you do that, yes, you can, the standard gene-centered inclusive fitness calculation of which addresses the dynamism, how fast that allele is increasing or decreasing, works. But then when you do that, you cover all cases of evolution in a trivial exercise. You have a very abstract way of describing the dynamic of gene frequency change. But you are no closer to explaining the agents of selection and exactly what is happening or predicting the real conditions, the conditions of the real world in which altruism has risen. The mathematical models generated by the standard gene-centered theory are internally consistent. They can be translated with the right, definitions and operations to the model that I'm just suggested, but they are unproductive. They have done very little, given us very little in 40 years. They are, they're just the wrong model to use, the wrong way to think about it, and they use the wrong point of entry, I believe, into the theory. Now, the standard theory, which 40 years ago looked so promising, has proved to be, in my opinion, retarding in its effect. Researchers on the biology of social insects who have paid actually little attention to it, although it attracts a huge amount of attention in broader circles in science and public, they pay very little attention to it, except for a courtesy reference once in a while, have enjoyed, meanwhile, outstanding success in exploring the fundamentals of eusocial evolution in communication, in division of labor, colony population, life cycles, ecology, phylogeny, all of which are reviewed in the forthcoming book for the fall next year, The Supoerorganism by Bert Holdobler and myself. And these fundamentals of empirical study, of intuitive guidance, of experiment and field study by large numbers of investigators, these, not the standard theory, has provided the means to track the origins of altruism and eusociality. So I'm going to be real harsh now. What has the standard theory contributed over 40 years? Actually, as I said, very little. It's the following: the prediction of conflict within colonies over sex ratios of investment in the production of new reproductives under certain conditions. It predicts that, if you think that's terribly important. And also it predicted the lessening of aggression among competing reproductives within colonies when they are closely related. That you could do, I think, intuitively. It has also stimulated a large number of measurements of pedigreed relatedness that would not have otherwise occurred. It's enriched that field. It has created a small industry of model building. Otherwise, it has added very little, if anything, to the mainstream of social insect biology, while often being erroneously in the popular literature represented as the mainstream in textbooks and popular accounts. So with that, I realize that this has been something of a gauntlet thrown down, and it has received strong critiques from those who whose work is, built into the standard theory models and so on, and we shall see what happens. Over to you, Mark.
So it seems to me that there's sort of a couple ways in which we can sort of take on what you've just said. One is a narrow position, which is that the standard kind of kin selection models, looking at the genes I view, are not going to be sufficient to account for eusocial insects. So just for tonight, since we only have half an hour left and I want to maximize it, let's give you that. Okay? It seems to me, though, that in some of the writings, especially some with David Sloan Wilson that you've written recently, that you've gone way beyond that, which is to say the views that were espoused in sociobiology were not just about eusocial insects. It was about the use of the sort of the Hamiltonian, Williams, Trivers views about looking at the level of the gene to account for social behavior writ large. It's from those ideas that things like parent-offspring conflict, parental investment theory, various aspects of mating decisions, game theory, reciprocal altruism spawn not just theoretical ideas, but mountains and mountains of research on all sorts of organisms. So as a student in those days, to me the exciting part was all the work that could be done that had just begun to kind of crest in the 70s, that now one can say behavioral ecology, sociology is dead because the theory was right. So one reading of it is that kin selection theory was right. It was so right, in fact, that there's not much left to do, right? That where people working in social behavior have gone is integrate molecular phylogenies, look at the neurobiology of decision-making and the economics of decision-making. But the basic ideas about adaptation at the level of gene were so powerful predictively that dotting the I's, crossing T's were done. So can you deny that?
Yes.
Okay, so what's wrong with the empirical work then?
Yes, what you're talking about is actually modifications of traditional Darwinian evolutionary theory. They did not really explain altruism.
Okay, say more.
Well, they just didn't explain altruism.
Well, let me give you an example, and you can tell me why you explain it.
Okay, let me back up for a minute.
Take Paul Sherman's classic example of squirrel alarm calls. The question is, why would an individual give a costly alarm call, drawing attention to itself, risking opportunities for survival, when that really goes against Darwinian thinking?
No,
right?
it doesn't. What it is, it's an example of group selection. In the social insects, we have innumerable cases of just that kind of behavior. It's group selection.
Group meaning kin group.
It means that alleles that cause the individual to respond this way are cause the group to which it belongs to survive better than the solitaires, and as a consequence, the alleles spread. Let me go back for just a minute and clarify by saying that it's useful. I think it's almost all-inclusive now to recognize three forces of evolution. Let me back up before that and say, let's make sure that we understand that the unit of selection is the gene. This has caused innumerable confusion because with the forces of selection. In multi-level selection, the gene can be selected, say, in a completely solitary species, strictly by what we call individual level selection or individual direct selection. Parent to offspring, whether or not the parent takes care of the offspring, and it might, and it might be very altruistic toward the offspring and so on. That is Darwinian individual selection. The next level, that's the target then, you see, is the individual and its offspring. The next level up, and that's what we've been talking about the whole time here, is the group. And the alleles affect the evolution, not just of individual properties, but also group-wide properties. These are the emergent properties, which we now are beginning to understand pretty clearly in the social insect, what they are and how they come about. So part of the phenotype is for an emerging group, social group with altruism, is that. The third possible selection force is collateral kin selection. In this, you within a group, you get together, within a group, you form an alliance with and become altruistic toward all those individuals that are most closely related to you. The evidence is all, in those social insects anyway, is running so strong against collateral kin selection, and that's what most people think of, when they think of the origin of sociality or bias toward the origin of altruistic sociality, is that collateral kin selection. But now even the major theorists who do mathematical modeling don't buy that anymore. So now we're down, as David Wilson and I showed, to it seems that the best way to explain evolution, and we're all using multi-level models, is to recognize that the unit is a gene, but the target of evolution is at in multi-level is the individual and the properties, the emergent properties of the group.
Okay, so let's go a little deeper on that, and then I want to shift this into something slightly different. Reading the paper with Davidson and Wilson, the quarterly review paper, which is a much more enlarged view of the one in the New Scientist, what you say is the evidence for group selection comes largely from microbial organisms.
And social insects.
And social organisms. But if you look at the early writings in sociobiology by yourself and Williams and Hamilton and Trivers, microbial organisms were definitely not the target of inquiry, nor was that where the predictive power seemed to have come from. I mean, as a student, it was, wow, so I can't explain why this individual would do a lot of, but by thinking about kinship, I can set up experiments, so if I put you next to kin and non-kin, I should get different kinds of behavior. So the predictive power was extraordinary. Now give me something back there for how to go forward with non-eusocial insects and non-microbial organisms that's going to change the face, because that's what the argument seems to be in qualitative biology. It's a change in the zeitgeist that's going to really change how we do our work.
Mm-hmm.
That I'm not seeing.
That you what?
That I am not seeing. I am not seeing how the change in my total worldview in 1975, which got me to think of thousands of experiments, how group selection is going to get me to do something similar, or has gotten anybody to do something similar with non-microbial organisms or insects.
Okay, well, I'll tell you how it's going to change things. It's going to focus attention now by comparative studies and by perhaps the utilization of masses of information available on hunter-gatherer societies and the paleo-anthropological evidence and so on the pre-adaptation. When we say, why did human beings become, what started the whole process? The answer is going to lie, if we ever have it, in the discovery of the pre-adaptation. Okay, now, the other thing that the new view provides an emphasis on that has left pretty much undone, maybe as I've said, I'm not prepared to go into human biology right now so fully, although I think maybe the approach I'm talking about would be heuristic. The second is, what are the pressures? What are the emergent properties, and what were the selection pressures on them as humans evolved? And I don't think we have that answer. We're beginning to get it for the social insects, but so what we're talking about really are two approaches to two perspectives that lead us into the study of the origin of altruism. By that I mean collateral altruism, not to your offspring. And I grant you immediately that tremendous advances have been made on studies of the differences toward immediate offspring, and also toward cooperativeness among people. But the explanations of them have been faulty of just what is happening. That's what I'm suggesting. You can come in through the individual, the inclusive fitness, come in there. And the theory tells us about what conditions that's what it tries to address. Under what conditions the gene frequency in multi-level selection is moving positively or negatively, and positively perhaps toward the formation of a cooperative group. But it tells us very little else. Only by distinguishing as the key players, the key forces, individual level selection, and that includes a lot of what you've done, versus group level selection, that we really begin to ask the questions that matter and can be addressed empirically.
Okay, so let's even though you're not yet ready to go to humans, let's go to humans tonight.
Okay. Well, David Wilson is, and I had to go along with him enough to let him make that suggestion in the paper that maybe we better have a closer look at the same thing for humans.
Yeah. So take for example arguments, for example, that Sarah Hrdy has made, that one of the ways in which we have evolved uniquely is perhaps as kind of cooperative breeders. We're a kind of cooperative breeder, right? And in various areas of now behavioral economics, where people have used kind of traditional economic games to look at how humans strategize and make decision making, some people have argued that whereas reciprocal altruism in the truest sense turns out to be very rare in the animal kingdom, very little good empirical evidence for reciprocal altruism, humans show it, and perhaps show it in a very unique way. So people have argued that, for example, humans in a situation where they can observe two players playing a game where one has given the other one a bad deal, and a third observer can punish an individual by incurring a personal cost, that humans will do that. They will do what people like Ernst Fair have described as altruistic punishment. I will incur a personal cost to punish you, even though, in theory, I will never know who you are.
Yeah.
Okay, so that would be an argument, people say, for group level selection, because there's really no kinship to be explained there.
It would, yes.
But that's consistent with group selection, but you could also imagine it's very consistent with kin selection.
All right, we need to disentangle them, as we've now done with the social insects. Or doing, yeah. Mm-hmm.
So, one of the things that seems to be elegant about the social insect story is, as you and Bert have now shown, is that you can get eusociality evolving without strong kinship basis, right? So one argument in favor of group selection is that you don't need kinship to evolve eusociality.
Not collateral.
Not collateral
kin selection. Obviously, you need direct selection. And you can explain it all by the emergent properties, even at a very primitive level, that come about by the appearance of an allele that allows plasticity. It has to be plastic, building on progressive provisioning, and then you have it all. In human beings, I thought you'd made important contributions yourself like this on the origins of altruism by group selection. That is to say, that maybe we are inherently moral, just as we are inherently ferociously territorial and easily given to group contest. Not because we are distinguishing kin so much, but because we are reacting to the ways in which our altruism arose by group selection. In other words, if you look at how groups are formed in humans and who can turn on whom, We see that what's the big question in human evolution, now I'm outside my field, but a big question is the way boundaries are defined. So if we recognize that in Nazi fascism the boundaries were done by some idea of geography and race, in others it is done by common religion, and others it is done by the idea of a nation, and so on. And that once these group boundaries are formed, then people can, they tend within the groups to become quite altruistic, cooperative toward each other, and shall I say at least very on guard and suspicious of other groups, right down to the National Football League.
Right. so I mean, at that level, I mean, what kind of parallel can you draw here between, then, let's say, the eusocial insects and humans? I mean, for example, one thing one could say is that it's only in the eusocial insects and humans that you see large-scale cooperation among genetically unrelated individuals. Now, one of the things you mentioned, I think, in one of the articles with David Sloan Wilson is that humans and other animals readily form ways of identifying and distinguishing among groups. Well, it's true that humans do that, but animals don't do that so well. And what humans seem to do relentlessly is create identity badges to identify who's in your own group and who's not in your group.
That's right.
And those badges are imbued with powerful emotions and beliefs.
That's
when you
right.
look at traditions in animals, you don't see anything of the kind. So
No.
a chimpanzee grooms this way in one population and grooms this way in another population, but nobody really cares, right? I mean, if you do it this way, it's fine. But it's kind of like in Sweden changing which side of the lane you drive on. As long as everybody agrees, we're okay. But, you know, go to Israel and tell them that they should now be Muslim. That's not going to go over very well, right? Okay, so humans have created a way of marking badges of identity that isolate groups, which can then create this very strong inter-group competition. So Boyd and Richardson have many models of cultural evolution where the identity badges and conformity are psychological ingredients that will propel this kind of between-group effect. What did the insects do?
Oh, this is fascinating. They do it. First of all, they have policing. And when you read the Supoerorganisms, I think you will be astounded by how sophisticated it is. But they police mainly workers who are trying to reproduce. And this is not kin related. It is colony fitness related. If workers decide they're not going to work anymore and decide they're going to reproduce, then they are reducing the colony workforce, and they are also adding unneeded offspring, which probably in most cases, because this is a haplodiploid system, are going to produce males, not more workers. So there are very strict policing techniques which are used. It's not based on kinship, although the studies, as I just mentioned, show that if you are closely related, you'll be, in some cases at least, you'll be a little less severe about policing. But that's a minor consideration. Policing is based upon the chemical evidences that the ant is turning, or the ants we know best, is turning into a reproducer. Mm-hmm. And when it starts turning into a reproducer, we now know the neural endocrine pathways, and we know what happens, what exocrine organs now generate changes, and we know what the changes are in the epicuticle, in the hydrocarbon mix, which change and identify with a flick of the antenna on that individual. One that is trying to become a reproductive, is a failing reproductive, or is a good, faithful worker. And they pounce on them. Let me tell you how the ants do it too. So it's a very generalized, highly genetic, hard-wired way of responding. The group, what are the group labels? I'm glad you brought that up. Certainly, one of the real differences is the one you just mentioned, which is, you know, as I said, the arbitrariness almost of group boundaries, and then the labels we use to identify them, reflecting probably an ancestry in which group versus group was the driving force of evolution that had to do with intelligence, altruism, heroism, and so on. But the ants identify a group in a very simple way. And missing this, I think, or forgetting or never knowing the literature is what threw some of the mathematical theorists off on the wrong track. They imprint on the first odors that they encounter in the first day or so of their life after they come out as an adult. And it's possible in experiments to take ants of different species or even different genera and let them come out from the pupae at the same time, and they form the colony. And that's they fight anything, including their own real sisters, that you put near them. But they'll be, walking along. It looks like a scene out of Star Wars. They'll be walking along some monstrous large thing that looks radically different, feeding each other and so on, because they went into that imprinting process very early. So it's a powerful mechanism, and it portends, or it suggests that there's a very powerful selection mechanism, and that the targets of selection are these properties that allow identification of group that you're in, and also what to do about cheaters.
So let me ask just one last question and open up with some questions here.
Yeah.
I mean, one of the added ingredients to the story that seems to me of interest in comparing the ants with humans is all the extra psychological gear that humans seem to have had to evolve to get the kind of high-level cooperation we see, which of course the ants didn't. So one of the things that seems to be necessary, at least in some of the models that people like Rob Boyd have written, for the evolution of cooperation among non-relatives in large groups, is that you not only need punishment of cheaters, i.e. your ant policing, you need punishment of those who don't punish cheaters. So if I was an ant and said, you should be punishing that guy, and you're not, I'm going to come clobber you, because that's the way I avoid free riders. Okay, so that's kind of punishment on top of punishment. Right? The second thing, which I noticed myself doing as we were talking, is what seems to be very rampant in human psychology, which is that we tend to conform to others very, very quickly and unconsciously. This is what the social psychologist John Barr just talked about as the chameleon effect. So there was a nice article about him in the New York Times a while ago where people bump into an experimenter unbeknownst to them in a hallway, and in one case they're holding a hot cup of coffee, in another case they're holding a cold cup of coffee. And the experimenter simply says, could you hold my coffee? And then later on they're asked, what do they think about that person? Well, if they were holding the hot cup of coffee, they think the person is warmer and kinder and nicer. And if it was the cold cup of coffee, they're colder and not so nice. So we readily kind of turn our colors like the individual we're like. And this creates these kind of in-group biases and, of course, out-group biases. So what's interesting to me about the ant-human comparison is that ants have solved this problem without having to evolve all the psychological machinery that seems to have been necessary in the evolution of human large-scale cooperation and morality. Because you have primates that are not doing anything near what we're doing at the level of cooperation. And then you have the ants who are doing it. So you've got two different solutions, presumably some kind of convergent evolution, but with completely different mechanisms. So maybe this is a last comment. Do you think there is some chance now, because of writing about consilience, of thinking about human cooperation on a scale where we begin to integrate across these different levels? Well, group selection, different kinds of selection will actually help predict where to begin looking at some of the psychological machinery.
This is where I think biologists and like me and anthropologists and like you will now begin to have a much more fruitful discussion. And as a preliminary answer, I would put the reason for that difference is that ants are too stupid to do it any other way, and that humans are the only species that ever managed it without having genuinely altruistic non-reproducers. We have found, I think, that even those who are institutionally supposed to be non-reproducers are often not. And so I see this as a very fruitful way of proceeding forward. I'm hoping that after this book is, out, I mean, even before then, I can start rethinking myself human behavior, and I may be around to talk to you.
Perfect.
Thank you.
So let's take a few questions.
Yeah.
insects have been around for hundreds of million years.
110
Yes.
million
And
years.
their altruism has evolved over the time. Do you feel that the altruism on human level will improve?
Now that's an interesting question. Not genetically, but it seems to me that what we need badly in our international political discourse is the recognition that hostility toward other groups, this hair-trigger response we all have, overreact, go to war, destroy the infidel, whatever. What we tend to do is regard this as a kind of pathology. In other words, we're just not being human enough. But unfortunately, we're being all too human. So if we can find a way of coming to understand that, and then this is where biology and anthropology need to work hard to try to present a more solid and convincing explanation of what humanity is and where it came from and why we behave. And we're such a strange way, we're a bizarre species. Then this information might be at least a moderating influence on religious extremism and political aggressiveness. That would be my hope. We always say that, as Abba Eban once said, that men, at the time of the 1967 war, that men will turn to reason when all else fails. Well, if we keep trying that other thing, we're going to kill ourselves. So we have to turn to reason. And it seems to me that what we're talking about tonight may or may not be quite correct. We're in the early stages of developing some of these ideas, and I wouldn't want to tell people to look at the ants, because ants are the most warlike genocidal species on Earth. But where a little bit better self-understanding might help us moderate our behavior. That could be a start. Thank you for asking the question.
Here, Ed.
Well, hello, Dan.
You anticipate getting lots of challenges from the tradition you're attacking, and let me try something more ironic, more a peaceful coexistence movement. As I heard you talking about your reasons for saying that Hamilton, Trivers, Maynard Smith standard view was insufficient, it occurred to me that really what you seem to be saying, since you allow that the gene is still down there, it's still the unit of selection, and their maps aren't wrong, it's just you don't think they're helping very much. Really what you're doing is making what I would call a plea for ecology in the following sense.
Yeah.
You're saying they caricature. Hamilton says, well, I don't know and I don't care what the ecological conditions are under which the phenotype of one individual can benefit the genes in its kin. But if there are such conditions, and under those conditions you could get altruistic behaviors evolving. And what you're saying is, look, those conditions, the conditions where there are opportunities for the evolution of altruism, are primarily ecological opportunities. They all have to be in place, and as you say, there also have to be some pre-adaptation. It's really what you're saying is, in order to understand groupish phenomena, you should pay more attention to ecology and less attention to genes.
That's partly what I'm saying. I'm also saying that the idea of, for the social insects anyway, and I think microorganisms, is that the idea of collateral kin selection, which is a phenomenon that seemed to be the key as you will remember. That idea is dead, and that changes an awful lot. What it says now is that we really need to focus on the other two countervailing selection pressures, and that analysis, both in theory and also field and experimental work focused on them and the countervailing power of them, is the best way to advance sociobiology. True, you can get from inclusive fitness and gene-centered, this is dynamics, to an equivalence with the group selection and countervailing two forms of selection explanation focused on group selection. But that's, as the old Southern hymn used to put it, that's up the rough side of the mountain. In other words, that's an unproductive way to approach the whole problem. And all that it's given us is an awful lot of confusing mathematics and changing of the definition of, or making extremely abstract the definition of the R factor, in the Hamilton equality and so on. And it's been a terrible struggle for the mathematical theorists to continue down that route without just making it so abstract and remote that it has little heuristic value. So you're right, yes. In a sense, I could say, well, now we have to turn to ecology, but we must turn also to closer studies of exactly what is happening, of a potentially selective, genetically selective nature in the contest between group and individual level selection, and what are the emergent traits in the group, and so on. A few of these questions have been asked. Now that's where we want to go. Thank you for the ironic suggestion, and it's probably the way we'll end up. But gradually, what I want to see is the mathematicians who've been struggling with traditional gene-centered selection models, and those models are getting harder and harder to read and more boring. I want to see them rather quietly leave their workstations and come over and start working on theory that is clearly more heuristic, because we've got a wonderful world out there waiting to study, in which now empirical information that we get from the field of what's going on can, in the best tradition of the physical sciences, be addressed by the kind of theory that will actually help the empirical part along.
Let's take one more question in the middle there. Yeah.
Returning to your question and discussion as to whether or not the mechanism for altruism would be perhaps completely different in higher creatures like the humans than in insects.
Phenomenon of altruism, yeah.
Back in '75, I wrote you a letter of support, and you graciously responded. 20 years later, I wrote a book called Neurotheology because I said if Wilson writes a book called Sociobiology, he starts it, and that's sort of neurotheology. Now, it's hard to synthesize, but it could be genetic, but it isn't entirely theoretically a mechanism that is possible. That before, about 40,000 years ago, there's no indication that human beings could consciously remember or project. That a small change in the genetic prefrontal cortex could give you the possibility of a chronological memory, which gives you a chronological future, which gives you a reason to be good, because what might happen? But it's a small change in the prefrontal cortex genetically, rather than a change perhaps at a simpler point.
Well, you're very right, and I don't think we've begun to address the question, why couldn't the Neanderthals get it right? They had, they had plenty of time. They had a couple 100,000 years. And why did it take Homo sapiens almost forever to get it right? Was there a genetic change that occurred? What kind was it? Was it some sort of rare cultural event that started it going? These are hugely important questions, I wouldn't even begin to guess, but I'm pretty sure that we'll be addressing them more and more in the future.
I'm glad I quoted from page 3.
Well, thank you.
So I think we'll end tonight, and we'll hope that you'll come back and visit us next year and talk about humans.
Okay. Thank you. That's a real, it was a fine